All right, so that was a little intro video of what we're doing today on limits. Okay, let's talk about limits. I want you to think of limits as traveling different paths on an airplane, okay? So we're asking what number is the equation approaching, given a specific standard, okay? We're just going to call this A. This green dotted line is A, okay? Its value is A. Now, if you will notice here, this is the notation for limit. There's an extra piece, an extra special piece right here. This negative right there, which means I'm approaching from the left-hand side, okay? This one has a plus, so I'm coming in from the right-hand side, okay? And no symbol means at exactly that point, all right? So if I were traveling from the left, I'm coming in from California. So I'm going to take this flight path right here, right? And when I approach A, what is my value? 3.8. So from the left, my value would be 3.8. Now, if I'm approaching from the right, I think of it as I'm flying in from New York. So I'm taking the plane, and what value am I heading towards? 1.3. Now, what type of discontinuity is this right here? It's a jump. So at exactly A, is there one clear answer? No. And if you think about it, when we discuss functions, in order for it to be a function, we had to have that one-to-one. And in this case, it's not one-to-one. I have two options. So if there's two options and not a clear defined option, we say that the limit does not exist. I abbreviated. This stands for does not exist. You are free to abbreviate, but I want you to write down what the abbreviation stands for. Okay? Good so far? That only occurs when there's not a clear defined answer, when there's jump. There's some other instances where it's undefined that we'll get to momentarily. I'll show you an example. Okay? All right, let me pause for a moment. Okay, so you have this paper before you, and now we're going to talk about something that we talked about the opening week of school. We're going to talk about discontinuity. Looking at the graph from left to right, which is the first point of discontinuity that you see? -2. And what type of discontinuity is that? That is a jump. Okay? And the next type of discontinuity that you see? +2, and that is infinite. Infinite. And the last one, and that is, it is a whole, but what is the proper name? Removable. Okay. So now let's talk. Okay, well, let me give you a second because some pencils are still going. Okay, when I have a jump, is there one clear value? When there's a jump, is there one clear value? No, there's two opposing values, okay? In this particular case, it's tricky, but this actually, they're both headed towards positive infinity, okay? So some people would say infinity, some people would say it does not exist because you can't determine infinity, okay? So this one could go either way. However, if one of them was going towards positive infinity and one is going to negative infinity, that's two different values. So that one would definitely be does not exist, okay? And I have two sides of a graph, yes? On both sides of these graphs, is there one definite value that it's heading towards? Is there a value it's heading towards? It doesn't have to hit exactly. It is heading towards. Yes, it is heading to one value, the value of 1. So removable does have 1 at exactly the point, okay? And we'll look at some clearer examples of this, okay? So jump at an exact value would not occur, okay? Infinite, if they're both going to the same infinity, you can go ahead and use that infinity. You could also consider does not exist. And removable is going to be a value, even though that it doesn't equal that value, it is heading towards it. As it's going in that direction, what value is it heading towards? That's what a limit is, okay? So, give me a second to put the picture on the screen to make this easy. Okay, another area of confusion is with these extra symbols. Now, this is talking about the value of -2 from the right-hand side. -2 from the right-hand side. So right hand, is that New York or California? New York. So we are going to head towards -2 from the right-hand side. Okay, so I'm traveling from the right-hand side. And what value am I heading towards? I'm heading towards 4. Does everyone see that? Okay. When x is -2, okay, here's -2, the graph on the right-hand side is at what value? 4. You want to give the y value. Okay, the y value. Okay? All right. So let me take out a highlighter. -2, yes? On the right-hand side, okay, trace the graph from the right. I traced it. It ends there. What is the y value of that end point? 4. That's where the 4 comes from. Okay? Now I'm going to go to -2 from the left-hand side. -2 from the left-hand side. So that's this side. What is the y value? 1. Okay, now I'm going to talk about that. So on your paper, I did not give you the exacts, okay? We were working on the left and the right. If you would like to add the exact, you can. At exactly -2, at exactly -2, which is right here, what is my limit? At -2, what is my limit? At exactly -2. It does not exist because there are 2 options. Okay? Okay, so let me go back. When I travel from the left-hand side, I stop at this point. What is the height of that point? Because it said from the left-hand side. Okay. It should be, sorry. Yes, it should be a negative. Sorry about that. So fix the typo. This one should be plus, this one should be negative. Sorry. I didn't catch it. All right, are we good? Okay, I'm going to add an additional piece because some of you are obsessed with the filled in dot. Yes? You see this filled in dot here? Okay, so some of you didn't want to say does not exist. You wanted to give me that value because you're like, my eye jumps to the solid. But you can't do that because the limit, I'm not sure because I don't know which side of the line I'm traveling on. Yes? Okay, if, however, I had asked f of -2, what would you say? You would say 4. That's when the colored in dot has that extra meaning. Okay? I know it's a little bit to take in. It's your first intro. Okay? All right. So now I am moving on. Your paper has +2 next. Yes? Does your paper have +2 next? Okay. +2 from the left. From the left. Okay. So here's +2. And let me erase some stuff so you can clearly see what we're talking about. All right. So now I am looking right here. Yes? And from the left-hand side, where am I heading towards? Infinity. It is the left because it's negative. Is your paper negative in that corner? Okay. Now, it is asking from the right-hand side. From the right-hand side, as I approach 2, what am I heading towards? Infinity. At exactly 2, what is it going to be? What are they both heading towards? Infinity. Okay. Yes, there are 2 different paths, but both paths are heading towards positive infinity, so we can go for infinity at the limit as x approaches 2. Yes. Okay, so backtracking again. Right here, there's a jump, right? Do I have a, if I ask you for the limit at -2, can you give me a clear answer? Yeah. Okay. On your paper, you have this. Okay? I am now speaking to the exact limit, which is not on your paper. And we will get to it later, but some people wanted to add it to their paper. Yes. You sure? Okay. All right. Let's look at the last one, and then we're going to do some more practice, and little by little it should sink in. All right. Now we're at 4. We're concentrated on 4 right here, okay? And I'm coming in from the left. When I approach from the left, what is my value? 1. When I come in from the right, what is my value? Okay, now this is not on your paper. The limit at exactly 4. The limit at exactly 4. How many options are there? How many locations are marked at 4? 1. And that y value is 1. If there is a single value that both sides of the graph are heading towards, you have a limit. The limit is 1. Now, the difference is if I had asked f of 4, that would be does not exist because the dot is not colored in. But the limit exists. Here, the limit does not exist because there's 2 different paths that I could be traveling on. I don't know which path I'm on. Okay? So this would be does not exist. Yes. For, okay, sorry. Ask your question again. So if both of these had been open circles, it would be does not exist. Good question. If both of these had been open circles, then this would be does not exist also. It can only, this is saying, looking at my function, when x is exactly -2, what is my output? And you can only have an exact for a solid piece of graph. An open graph does not have an answer. Good? All right. Okay, This should be on the back of your paper. Yes? We good? Okay. So they want me to head towards 1. So I'm going to highlight 1. There's 1 on my graph. Okay? Everyone follow? Okay. Positive. What direction am I coming in from? The right. So I'm coming in from California. Sorry, New York. I messed up the map. Okay, so I'm coming in from New York. Where am I heading towards? Infinity. Good? If there's a little plus sign there, that means you're coming in from the right side of the graph. And if it's a negative, you're coming from the left, which is the traditional direction that we normally read a graph. Good? Okay. So now it wants me to come in from the left. So when I come in from the left, which way am I heading? Negative infinity. Now, are these two answers in agreement? No. So at exactly 1, can I have a limit? No. I'm not going to have a resolution because me and my friend are fighting over the movie. Okay? So this is going to be does not exist. Right? This graph is heading towards negative infinity. This one's heading towards positive infinity. I have 2 opposing values. Therefore, at exactly 1, I don't have a limit. I can't determine the limit. We couldn't decide on a movie. Right? We got getting better? Okay. All right, let's look at another one. Okay, here we go. Good one? All right, so they're talking about 1. So what I like to do, you don't have to do this, but I identify the number and I mark it. There's 1. Okay? You don't have to do that. That's just a personal preference of myself. Okay? All right. So positive means I'm coming in from New York. When I come in from New York and I hit the pink line, yes. No. Whatever number it is, that's your final destination. So that's why I put this vertical line. Okay? Yeah, for all of those. The plus means I want to look at the right-hand side of the graph. So I'm traveling from the right-hand side. When I get to that pink line, how high am I? 6. So the limit is 6. No. I put the line at 1 because that is the reference number in the problem. Okay? All right. Now, this one is negative. So I'm coming in from the left-hand side. And what height am I at the pink line? 6. Are my 2 answers in agreement? Therefore, does the limit exist? At what value? 6. Trick. All right, all right. Now, does that exist? Why does f of 1 not exist? Because it's an empty hole. So this one does not exist. Do you see the difference? Yes, ma'am. You always start at when it's negative, you start at the left. And this number is your stop. So I come in, I'm flying in from California. Whoop, I stopped at this airport. What's the name of this airport? 6. Okay? It's saying at exactly that number. So a good trick is do left and right. And if left and right are the same value, that's going to be your limit. If they're 2 different values, it does not exist. Does that make sense? So let's start again. I mark with a vertical line. I look at the left side and at the right side. If they both meet at a single point, doesn't matter if it's open or closed, the limit exists. If they're going haywire, I don't know what the limit is. Good? And because they didn't give me a direction, they gave me exactly that point. Yes, sir. It's not on the paper. I was just, f of 1 is when, f of 1 means when x equals 1, y equals question mark. So when x is exactly 1, I don't have an answer because there's a hole. Okay? If this had been colored in or a solid part of the graph, I could give an answer. It has to be solid to give an answer for function notation. If this was colored in, the answer would be 6. All right. Moving on. Woo, this one's a little tricky. Those stair steps. My goodness. All right. So, where am I going to put my vertical line? At 2. So, let me put the vertical line and hope that I don't mess this up. There's 2. All right, they want me to travel from the right-hand side, okay? Doot, doot, doot. All right. So what's my height? 1. Yeah, that plane was having issues. Is that what you're telling me? Okay. All right, so now I'm going to come in from the left-hand side. Doot, 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 doot. I picked a bad color, sorry. And what's the answer? 0. So at 2, does the limit exist? Why? I got 2 opposing values, so it does not exist. Because when I got to this line, right? No. The first spot that you hit the line. So once I hit the line, I'm not going to keep going. Once I hit the vertical line, I don't go past it. I don't travel on it. I don't go past it. Got it? Once you hit the line, you stop. You don't travel on the vertical line. Okay? Especially when it's, yes. And okay, so the limit is not, because if you think about it, this is a jump. Yes? No, that's for function notation. So if I said f of 2, you would say 1, because that's where it's filled in. Okay? I know, because you guys are so used to function notation and having an exact answer, sometimes math isn't pretty. So let me reiterate. You put your vertical line in. When you travel, the first spot that you hit that vertical line, you stop. Do not travel on that vertical line. Okay? And then that points out that there's a jump. Because when I traveled here, oh, I hit the vertical line, I'm going to stop. It's at 1. Whoop, I hit it. It's at 0. I stop. They're opposing values, so it does not exist at exactly that location. The function value does, but the limit does not. Good? Yes, ma'am. Oh, so when I travel, tell me when I hit the vertical line. Stop. What's the height? No, what's the height? 1. So you're always giving the height. You're always giving the y. Okay? Yes. When you're traveling from the right, you go right to left. And when you're traveling from the left, you go left to right. F of 2 just means go to 2 and find the exact value. Okay? All right. That is that. I'm going to give you some practice problems.